you seeing the screen? Mnaona Victor, mnaona screen? Inaanza? Imekuja hiyo differentiation? Okay. Good evening, class. Today we are going to look at differentiation, that is solving a trigonometric and exponential function using the product rule. Remember, in the last lesson, we looked at how to do a common differentiation. That is, given a function, you are able to do a simple differentiation. But as of today, we are going to do using the product rule. So by the end of this lesson, you as the learner will be able to identify a function that appropriately needs a product rule to solve. Then secondly, you'll be able to solve a trigonometric and exponential function using the product rule. Therefore, the first thing that a person does when he wants to use this rule is you must identify if the function formed is a result of a multiplication of two or more functions. Then, if this is not satisfied, then you'll use other rules, and therefore you'll discard using the product rule. So here below, I have placed some functions that I want you to identify whether these ones are products of a multiplication or not. The first one is y is equal to 3x cubed plus 5x squared plus 2x minus 4. As you see, these ones have several multiplication, like 3x cubed, that is a multiplication, 5x squared, that is a multiplication, but they are not functions. Remember, it's not a full function. Therefore, let's continue. 5x cubed, 5x exponential 3x, that is a function that is a product of a multiplication. Then we have 5x cubed ln y, that is also a function of a multiplication. Then we have sine 3x over 5 cos 4x, that one product rule will not be appropriate. Then we have y is equal to 3x plus 5. That one also, the product rule will not be appropriate. Therefore, just as a recap, we are going to see how to differentiate just a common function. Like for example, in our case, we have 3x squared. Now, in order to differentiate this, we'll have to take the exponent, that is 2, and multiply it by 3x. And then from the 2, we are going to minus 1. That will give us 6x power 1. And as you know, x power 1 is the same as x, so the answer will be 6x. The next one, we have another quadratic function, but this one has got one unknown. Some, you'll find them having two unknowns, x and y, whatever. But for this one, we only have x, therefore we have 5x cubed plus 2x squared plus 5. And in this, you remember that we have a constant that is 5. So when we differentiate a constant, we have a 0. Therefore, when we differentiate this, we'll have 3 times 5x cubed minus 1 plus 2 times 2x squared minus 1 plus 0. This one will give us 5x squared plus 4x power 1, which will give us 15x squared plus 4x. Therefore, in order to solve using this rule, there is a formula that you've been given here below. 2y dy over dx is equal to u dv over dx plus v du over dx. And therefore, from this function, we don't know u, we don't know dv over dx, we don't know v, we don't know du over dx. And therefore, we have to generate this. Then, after finding our u and the v, we are going to use our u and v to get dv over dx and du over dx. Therefore, as our first trigonometric function will be 2x cubed cos 3x. And on the right, we have a table where we can use to to do differentiation of particular functions, trigonometric functions. Therefore, cos x will give you minus sin x will give you cos x, tan x will give you cos x, tan x will give you sec squared x, and ln x will give you 1 over x. And therefore, from our function given, we'll get our u, which is 2x cubed, v, which is cos 3x, dv over dx, that one you get when you differentiate. U is equal to, v is equal to cos 3x, that one will give you negative 3 sin 3x, and u is equal to 2x cubed. When you differentiate that one, will give you du dx, that is 6x squared. And then when we substitute this into our formula, we have 2x cubed minus 3 sin 3x plus cos 3x into 6x squared. Then this one will give us minus 6x cubed sin 3x plus 6x squared cos 3x. That is when you multiply these factors. We open the brackets. Then when we factor out, we have a common factor, that is 6x squared. And then in bracket, we'll have cos 3x minus x sin 3x. Then let's look at another one. Now, this one is now an exponential function, which is exponential 3t sin 4t. Then using the same formula, we find that dy over dx is equal to u dv over dx plus v du over dx. And when you look at the right, you will see that table where when you differentiate exponential x, it will just remain exponential x. And therefore, when we differentiate exponential 3t, it will remain exponential 3t. Now, our u will be exponential 3t, v sin 4t, dv over dx will be 4 cos 4t. That is using the previous table. Du over dx will be exponential 3t. And then when we substitute them into the formula, we have exponential 3t, 4 cos 4t, plus sin 4t exponential 3t. Then there I've written, note the arrangement. Make sure that everything falls into place. U inakuwa mahali pake. Dv over dx comes to its place. V comes to its place, and du over dx comes to its place. And then when we open the bracket, we have 4 exponential 3t cos 4t plus exponential 3t sin 4t. Then we realize that exponential 3t is common. Then we factor it out, and we have 4 cos 4t plus sin 4t. Therefore, since you are now comfortably able to solve a function, given a function that needs to use the product rule. Now, these are the exercises that you are going to do, and I believe the class rep is going to be able to collect the scripts so that you can be able to look at them. Now, the first one is fx is equal to 2x cubed plus 1 in bracket, and x squared plus x in bracket. That's another one. The next one is x squared. Fx is equal to x squared sine x. And then the other one is fx is equal to sec x tan x. And the last one will be fx is equal to exponential 4t cos 5t. That one is not there, but make sure you note it down. That is exponential 4t cos 5x. Now, let's continue. Now, as a summary from this lesson, we have learned how to identify the salient features of a product function. That is, given a function, you are able to identify that this function I need to use a product rule. Then, next, after identifying that, you are supposed to derive the u and the v. And then from the u and the v, you'll be able to generate the dv over dx and du over dx. Then from this, you'll now be able to replace them into the function, and then from the function you're able to do whatever, is it to open the bracket or to factorize. Then from there you'll be able now to get the result of the what? Of the question. Now the third one was how to use the above, the first two above, in order to get the differential of a function given whether it's a trigonometric or exponential function. Now, with this one, I believe that you are now comfortable to solve any question given on finding the result of a function using the product rule. Thank you, and may God bless you.